Hey there and welcome back to our channel. Today we have an exciting tutorial for you. We will be building capacitance meter using an Arduino and a couple of resistors. This meter will help us to accurately measure the capacitance of capacitor, making it easy to label them for future reference. Now, as you know, capacitors came in different types and labeled in various ways, which can be confusing without a digital multimeter. It can be challenging to determine the value of the capacitors. That's where this capacitance meter came in handy. During my testing, I found this capacitance meter were accurate in microfarad range but failed in nanofarad and picofarad range. So I have come up with this meter that cover a wide range from about 1 microfarad to 4000 microfarad. Before we dive into building the circuit, let's understand how we can use the Arduino to measure capacitance. It all comes down to property of resistor, capacitor, RC circuit called the time constant or time response. The time constant is the time it takes for the voltage across the capacitance to reach 63.2% of its voltage when fully charged. Larger capacitors take longer time to charge, resulting in a larger time constant. The capacitance in RC circuit is related to the time constant through this equation. By rearranging the equation, we can solve for the capacitance. Capacitance meter we will build in RC circuit with known resistor value and unknown capacitor value. The Arduino will measure the voltage at the capacitor and calculate the time it takes to reach 63.2% of the voltage when fully charged. The time constant with known resistor value, we can use the formula in our program to calculate the unknown capacitance. Now that we have a basic understanding, it's time to start building the circuit and coding the Arduino. First, let's go over the component we will need for this project. Of course, we have the Arduino board, LCD screen, breadboard, fuse jumper wire, resistor, capacitor, for testing. Make sure you have all these components handy before starting. Now let's start by connecting our component. First, let's connect the Arduino, then LCD screen. After that, connect the two resistors. Take a look at the diagram on the screen for the pin connection. Now that our Arduino and LCD are connected, let's move on to capacitor. We will use the capacitor to measure the capacitance. Connect one leg of the capacitor to the ground and the other leg with the resistor. Great, now that everything is connected, it's time to write the code. We will be using the Arduino IDE for that. Here is the code we will be using. It's available in the video description below, so make sure to copy and paste it into your Arduino IDE. First, we define some necessary library. We measure the time it takes for the voltage across the capacitor to reach 63.2% of its fully charge using this function. Next, we calculate the capacitance using the measured time and the known resistor value. If calculated capacitance is greater than 1 microfarad, we display the value in microfarad on the LCD screen. After measuring the capacitance, we discharge the capacitor by setting the discharge pin to low and wait until the voltage drops to 0 using the analog read function. And that's it. The code allows us to accurately measure the capacitance of the connected capacitor and display the result in the LCD screen. Once you have uploaded the code to your Arduino board, you should be able to measure the capacitance of different capacitors. The result will be displayed on the LCD screen. It's a handy tool for electronic enthusiasts. Before we wrap up, I want to emphasize that this project is for education purpose only. It's not intended to be a commercial project. We are exploring the concept of capacitance measurement using an Arduino and sharing it with you as a learning experience. While our capacitance meter can be a useful tool, please keep in mind that it may have limitations and may not be accurate as dedicated commercial devices. Remember always, exercise caution with working with electronics. Follow safety guidelines and consult reliable sources for comprehensive information. Thank you for joining us in this education journey. Stay curious, keep learning, and we will see you in our next video.